Okay, for problem 1, here is our region between the line, y is equal to 2x, and the curve, y is equal to x squared. We are rotating it about the x-axis, so our rectangle is vertical. The point on the top of the rectangle is on the line. The line is farthest away from the axis of rotation. The bottom of the rectangle is the curve. The curve is closest to the axis of rotation. So when we set up our integral, we will be doing the line minus the curve and a dx because we are rotating it around the x. If you quickly look at the rotation, there's our line, there's our curve being reflected, our inner disk connects the curves, which are closest to the axis of rotation, and the outer disk connects the line, which is farthest away from the axis of rotation. All right, so we need a pi. We need a y squared minus a y squared dx. If we plug in our line, we have 2x squared, and if we plug in our curve, we have x squared squared. If I simplify that, everything in here gets squared, so that becomes 4x squared, and when we raise one power to another, we multiply. So there is our simplified integrand. All right, for the limits, again, everything matches the axis of rotation. So we are rotating it around the x, so we need the x values. The lowest part of that region is right here. The x value is 0. So our bottom of the big elongated S is 0, our left endpoint. Up here, the highest point of the region is right here. The x value is 2. So we are going from 0 to 2. And there is your definite integral. Go ahead and solve that using Math 9. Please check your answer. Number 2. Now we are rotating it about the y-axis. Can you see all this open space between our region and the axis of rotation? That is your tip-off that this is a washer problem. Open space between the region and the axis of rotation. All right, our horizontal rectangle is right here. The right of the rectangle is on the curve. Y is equal to 1/8 x cubed. So this curve is farthest away from the axis of rotation. The left of the rectangle is on the line. So this is closest to the axis of rotation. If we look at the rotation, we reflect those curves. The inner disk connects the line, which is closest to the axis of rotation. The outer disk connects the curve, which is farthest from the axis of rotation. So when we set up this definite integral, it is going to be the curve minus the line. All right, we factor out the pi. Remember, when we rotate it around the y-axis, all of our equations have to be solved for x. So we're going to go off to the side. We're going to take our curve, y is equal to 1/8 x cubed, and we are going to solve this for x. Okay, so the first thing that we're going to do is I'm going to multiply both sides by 8 to move the 1/8 over. So I have 8y is equal to x to the third. Now I'm going to take the cubed root of both sides. So I need to take the cubed root here, and I need to take the cubed root here. Now, the cubed and the cube root cancel each other out, so we have x. Instead of having a cubed root here, I'm going to rewrite it. A cubed root is the same as the 1/3 power, and that will be easier when we plug it into our integrand. All right, so that is the curve. Now let's take the line, y is equal to 2x. In order to solve that for x, we simply divide it by 2. So x is equal to 1/2 y, and that is our line. Now we're ready to plug them in over here for our integrand. So we need x squared here, and we need another x squared here. And this is a dy because it matches our axis of rotation. So when I plug in my curve right here, I'm plugging in this right here. So that becomes 8y to the 1/3. When I plug in my line right here, I'm plugging in 1/2 y. All right, let's go down and simplify that. Everything in here is going to get squared, so that can become 64. When I raise one power to another, I multiply, so that becomes y to the 2/3. All right, when I simplify this, over here, everything in here gets squared. So 1/2 squared is 1/2 times 1/2, which is 1/4. You could also use 0.25, and then it is y squared. All right, so if you have an older calculator, it is much easier to simplify than trying to punch all this in. If you have a newer calculator, you can probably go right from here. All right, now we need our limits to complete our definite integral. Let's go over to the picture. The limits are along the axis of rotation, so they are from low to high. This point right here, of course, is 0, 0. We need the y value. So our left endpoint is 0. And then up here, that coordinate point is over 4 up 8. Again, we need the y value. So our upper limit is going to be 8. From 0 to 8 along the y-axis. So there is your definite integral. You can use Math 9 to solve that. Please check your answer.